I'm Evan Hartnett, and this is my Physics 2212 Lab 1, Charged Tapes. The purpose of this lab was to use charged pieces of clear tape to observe the transfer of electrons between surfaces and to determine approximately how much excess charge and electrons are on a piece of charged clear tape. For a basic overview of my results, I found that once charged, the pieces of tape repelled each other. I determined that the charged pieces of tape were positively charged. I determined that the charge on each piece of tape was approximately 1.98 times 10 to the negative 8th coulombs, and I determined the number of excess electrons to be 1.24 times 10 to the 11th electrons. The physics principles I used in this experiment were using tape to model point charges by assuming equal distribution of charge on each piece of tape, Coulomb's law and Newton's second law to calculate the charge on each piece of tape, approximating the dimensions of an atom to calculate the number of excess electrons per atom, electric fields and forces on an object due to an electric field, with the system being 2 U-tapes and the surroundings being everything else in my room. The assumptions I made were that air resistance is negligible, treating the long tape as though it were a point charge with all charge concentrated at the center, assuming each U-tape had about the same amount of charge evenly distributed along the length of the tape. Pieces of tape are neutral until ripped off the table and charged, and in the case of the floating tape, gravity and the electric force from the other tape were the only significant forces acting on it in the y direction, resulting in a net y component of 0. The experimental procedure for this experiment was as follows. The initial conditions consisted of placing 2 pieces of approximately equal in length neutral tape on top of a third piece of neutral tape on my desk. I then charged the tape pieces by ripping them swiftly off the third base tape. I then tested the charge of the tape pieces by holding the pieces near each other and other objects. I then placed one piece of charged tape above another until the upper tape began to float. I then measured the distance of separation between the 2 pieces, and finally determined the excess charge from experimental values. My expectations for this experiment were that the tapes would have the same charge and repel each other. In the case that a U-tape was positively charged, it should be attracted to a negatively charged plastic pen, and conversely, if a U-tape was negatively charged, it should be repelled by the negatively charged plastic pen. Finally, a neutral U-tape would be attracted to the pen due to the charge of the pen. After performing the experiment, I observed that in fact the U-tape pieces did repel each other. The U-tape was attracted to my hand and other objects on my desk. The U-tape was attracted to the negatively charged pen, confirming that the U-tape pieces are positively charged and therefore lost electrons when charged. Here are my data and calculations. I was able to determine the surface area of my U-tape pieces by simply multiplying the length and width of them. I was able to determine the number of atoms by dividing the surface area of my U-tape by the area of an atom. I was able to determine the magnitude of gravitational force by simply multiplying the mass of my U-tape by the gravitational constant. I was able to determine the amount of charge on the U-tape by using the equation shown on the slide. I was able to calculate the number of excess electrons by simply dividing the charge on the tape by the charge of an electron. And finally, I determined the ratio of excess electrons to atoms by dividing the number of atoms by the number of excess electrons. To develop my model, I used the data that I collected during my experiment as well as some common constants and performed some basic calculations. On the left side, I used a red sphere and a blue sphere to represent the 2 pieces of U-tape. The red sphere represents the lower piece of U-tape and the blue the upper piece of U-tape. The blue sphere has arrows extending off of it to indicate the force of gravity, pointing down, and the electric force from the lower piece of U-tape on the upper piece of U-tape, which points upwards. For this experiment, some discrepancies between the model and my experiment included treating the pieces of tape as simple point charges, as well as assuming that charges on each piece of tape were equal. Had they been unequal, the values of charge, electric field, and electric forces would have differed significantly. Some sources of error in this experiment included potentially losing charge to my hand or even the air in my room as I was handling the tape, roughly estimating the weight of my tape, and additional forces from the surroundings that I did not account for. If the charges of electrons and protons were reversed, my observations would not have changed. The tapes would behave the same way. They would still repel each other and would float if placed on top of each other. It is important to handle the charged tapes as little as possible because when the tapes come into contact with hands and other objects, charge is distributed and the tapes return to being uncharged. They begin to gain back some of their lost electrons from other objects, which would affect the results of the experiment. To conclude, objects can be used to model point charges. Newton's laws are still very much relevant when considering the impact of electric fields and forces. Objects can be charged from something as simple as touching another object, and electric fields and forces play major roles in the interactions between objects in our world.